There we're recording. Okay. Newer FM transceivers provide digital voice compatibility or capability, commonly referred to as digital modes. Three of the most popular are DMR, D-Star, and System Fusion. And when I explained this a while ago, I told you those, but there are others. And I can't remember the names of most of them, but there's probably 4 or 5 others. And I can sit and look at my hotspot and tell you what they are. Next generation digital narrowband or something like that. There's several of them. But the most popular ones are D-Star, DMR, and System Fusion. DMR, in this area, we have one, like I say, there's a DMR repeater about 3 miles or so from here. There's another one in Titusville owned by the same club. D-Star, I think the closest one is in Orlando. I think you said 44 miles, something like that. System Fusion, C4FM. Yeah, these are all over the place. I think there's 2 or 3 in Melbourne and 2 or 3 here and more up in Titusville. Now, what I will say is that, remember I said D-Star is ICOM, and they license it out to Kenwood. So it's rather proprietary, more expensive. System Fusion, Yaesu only, more expensive. DMR is open source, and anybody wants to build a radio can put it on there. So it's very much less expensive. When I bought this radio, I think I gave like $85 for this radio. I think it's about 92 or 93 now. Okay, digital modes are popular because voice signals can be routed over the internet. Digital mode repeaters are connected to the internet. So the DMR repeater here is an internet gateway. If you're not close enough to one, then you can get a hotspot. A digital mode hotspot is connected to a computer on the internet. Digital mode radio can connect via a repeater or a hotspot, either one, to all other hams that use the same system all over the world. There are recently, when I set this up, I don't think they had this, but there's recent, what I'm seeing is that it doesn't matter which system you're on, you can talk to people on the other system, but there's a lot of setup that goes along with it, and I haven't taken the time to figure any of it out yet. What function is performed when a transceiver and a digital mode with a transceiver and a digital mode hotspot? Communication using digital voice or data systems via the internet. That is correct. When you do, Mr. Kruger, when you set up, if you decide to go Brandmeister, they're going to make you do you have to put in a security code, and all you do is go to your account page with Brandmeister after you create your Brandmeister account, and then you enter. Don't lose that security code, because it's a mess trying to figure it out if you lose it. So that's why I'm making no changes. DMR and D-Star both require call signs to transmit. So you have to get your call sign in order to get on the system. Digital voice transceivers must be programmed with your call sign. DMR requires call sign, color code, time slot, and DMR ID. A lot of requirements there. And for those who decide to get into this, you'll figure out what all those things are. The beauty of this initially was that in a 12.5 kilohertz wide band, you could have 2 signals. That's why they call time slot 1 and time slot 2. And so far, I don't know anybody that uses time slot 1. Everything is time slot 2, I think. D-Star requires a registered call sign before transmitting. DMR talk groups are selected by an identification code. So remember I said, talk groups are groups of users, and this is a test question, so pay attention to this. Talk groups are groups of users sharing a channel at different times without hearing other users. Remember I said I was talk group 91 is a worldwide talk group. I think talk group 3100 is USA talk group, or USA Bridge might be. There's bunches of them. I mean, you could never sit there and go through all of them. Code plug, and we all have a friend who argues the use of the term code plug, but code plug contains access information for repeaters and talk groups. So on the software for this one, when you get in there and you put in all your information, and for every channel, you have to go through the whole information process and put everything in it. You have to put the frequency, all kinds of things. It's a time-consuming process. But you build your information, and then you upload it from your computer to your radio through the cable that plugs in right there. And then you have all the information on there. There's further that you have to put, in order to make it the most friendly experience, you have to upload a list of users. And the list of users is well over 300,000 right now. So, and this one will only hold 80,000. So there's no way I can put all the users worldwide in here, so I don't even bother with it. What comes up on here on the screen when I hear somebody talking is their DMR ID. And then I have to cross-reference their DMR ID in my phone or in my computer to find out what their call sign is, which ultimately leads me to their location. So I've talked to people from England and people from Trinidad on there. So it's pretty cool. All over the internet with this antenna from inside my house. So, but that's your code plug. What is a talk group on a DMR repeater? Bravo, a way for groups of users to share a channel at different times without hearing other users on the channel. That is correct. What does a DMR code plug contain? Bravo, access information for repeaters and talk groups. How is a specific group of stations selected on a digital voice transceiver? By entering the group's identification code. There you go. What is the purpose of the color code used on DMR repeater systems? I don't know that we covered this. Well, it has to match the repeater color code for access is the answer. But the color code, the best way to explain it is it's like your PL tone on FM. So even if you have the proper uplink and downlink frequencies plugged in here, if you don't have the PL tone, it doesn't unlock the repeater. And the same thing is with the color code. Even if everything else is correct, if your color code is off, the repeater won't recognize it. Which of the following must be programmed into a D-Star digital transceiver before transmitting? Alpha, the call sign, correct. HF transceivers. HF transceivers have more controls than your typical VHF, UHF, FM transceivers. They may have many different receiver bandwidth filters, plus your filters can usually be adjusted on AM and FM, or on the FM, VHF, UHF, you usually don't have that option. A 2400 hertz filter provides the best signal to noise ratio for single sideband. If things are tight and people are talking very closely together, you can turn that down to separate the outer stuff away from it. 500 for CW. Now remember, does anybody remember what we said the CW bandwidth is? 150. So on my Zygu, the automatic decoder, I can only get it to work if I dial that filter down to 200 hertz. If I leave it at 5, and actually I don't think it defaults at 500 on the Zygu. I think it defaults at 300. But I turn it down to 200, I get much better performance out of the decoder than I would get at 300. And I'm pretty sure at 500 it might not even make the light up because there's a yellow light. If the yellow light is blinking, you've got it dialed in. But according to the test, 2400 hertz for single sideband, 500 hertz for CW. What is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? Permits noise and interference reduction by selecting a bandwidth matching the mode. Very good. Thank you, Greg. Which of the following receiver bandwidths provides the best signal-to-noise ratio for single sideband reception? Single sideband. Charlie, 2400 hertz. And let's see, HF transceivers commonly have a receiver incremental tuning or RIT control. I haven't played with this much, but it makes sense. It can offset the received frequency from the transmit frequency, and it can be used to adjust the voice pitch of a single sideband signal. The way it was described to me was if you got someone that you're talking to on the radio who didn't quite get to, and this is easy to do. This is easier than you would think for it to happen. You usually select on your transceiver what digit in the frequency is going to be your primary digit to increase or decrease when you turn your VFO. If you make it lower, then it takes you longer to get to places. If you make it higher, then you might skip over something. And that, I think, is where the receiver incremental tuning comes in, because if you're sitting there transmitting on, say you're transmitting on 14, let's say you're transmitting on 14.3, and someone's got you dialed in on 14.295, they're off a little bit. So it you know, and you're talking and you can communicate, but it's hard to listen to. So you can use receiver incremental training, incremental tuning to tune down to their transmit frequency. So your transmit frequency stays the same for your benefit and everybody else that you want to talk to, but your transmit, your receive is coming in on his frequency, and then you have to re-zero that. It doesn't automatically go back. You have to re-zero it. And it's usually not a wide amount. And there's also a thing called delta transmit on some radios, which does the same thing on transmit frequencies, and I really have not found a use for that yet. But this one here, I can see a use for it in some situations. So receiver incremental control, receiver incremental tuning, or RIT control, sometimes called a clarifier on the older ones. On Offsets receive frequency from the transmit frequency and can be used to adjust the voice pitch of a single sideband signal. In other words, you're going to use that to take the chipmunk out of their voice. Because that's what sometimes happens. Which of the following controls could be used if the voice pitch of a single sideband signal returning to your CQ call seems too high or too low? Delta, the RIT clarifier, RIT or clarifier. Some radios, I don't know that any of the newer ones are still calling it clarifier, but there are radios out there. And when you go looking for a radio, you might be looking at some older ones, and it would be clarifier on some of the older ones. Push to talk, or PTT, is common on all transceivers, and I make this mistake all the time with new people by calling it a PTT instead of a push to talk, and new people don't know what a PTT is, right? Okay, so PTT means push to talk. That's your transmitter button. Can be a switch on a microphone or a transceiver input signal coming from the computer, if you're using a digital mode. Switches a transceiver from receive to transmit when it's grounded. What is the function of the receiver's push to talk input? Bravo switches a transceiver from receive to transmit when grounded. So digital modes. Hotspots allow digital voice and data communications via the internet. DMR talk groups, a way for groups of users to share a channel at different times without hearing other users on the channel by entering the group's identification code. Code plug provides access information for repeaters and talk groups, and I'm pretty sure, is the code plug a D-Star thing, or is it just DMR, or does D-Star and Yaesu use it too? Okay. Okay. Ah, okay. Okay, so color code, in the case of DMR, your color code has to match the repeater or what is set up in your hotspot in order to get access. D-Star, your call sign must be programmed into the radio. HF transceivers, bandwidth filters, permits noise or interference reduction by selecting a bandwidth matching the mode. 2400 is best for single sideband. And what did we say was best for CW? 500. RIT, R-I-T, receiver incremental tuning. It can be used to adjust the voice pitch of a single sideband signal. Push to talk, PTT, switches a transceiver from receive to transmit when grounded. Any questions?
The use of the term internet kind of confuses me because when I think of internet, I think of Amazon, email, and stuff like that. I'm generally confused as to whether or not any of those kind of things can be done, or if internet is just the methodology using a codec to transmit voice.
Okay, so what happens is this radio right here has access to the repeater that's 3 miles from here, and I talk to that repeater from here. That repeater has internet access. On the other end, somebody with a similar radio and a similar repeater or hotspot is listening to my signal. Now, radio-wise, it gets from this radio to the repeater by using radio waves. On the other end, it gets from his repeater or hotspot to his radio by using radio waves, but in between, it's just going over the internet. And the internet, it's a communication, well, it's a communication method by sure, but sometimes you're communicating digital data, other times you're communicating voice over it.
So basically packet data.
Right. I don't know if it's packet. I don't know how that part actually works. Going from the repeater to him, it's by packet. Okay. So, yeah. Okay. No other questions?